In this passive question, we have positive ions traveling through a vacuum in a narrow beam. The ions enter a region of uniform magnetic field of flux density B and are deflected in a semicircular arc as shown in figure 5.1. This is the path taken by the positive ions. And this is the detector here. By reference to figure 5.1, state the direction of the magnetic field. The magnetic field is into the plane of the paper, as you can obtain using your Fleming left-hand rule. In part D, the ions have a mass of 20 U. U is atomic mass unit, and a charge of 1.6 times 10 minus 19 coulomb. Show that the magnetic flux density is 0.454 Tesla. Explain the working. The magnetic force due to the magnetic field provides a centripetal force. So the equation is magnetic force equals the centripetal force. Magnetic force is BQV. Then the centripetal force is mv squared over r. So your B equals to mv over rq. You get your V can cancel off. Then you can substitute the values into the equation. You get 0.454 Tesla. In part C, ions of mass 22U with the same charge and speed as those in B are also present in the beam. On figure 5.1 shows the path of these ions in the magnetic field of magnetic flux density 0.454 Tesla. The answer is the ions will be deflected to follow a semicircle with diameter larger than 12.8 centimeter. The reasoning will be given below here. Later I discuss it. Then in part 2, in order to detect these ions at a fixed detector, the magnetic flux density is changed. Calculate the new magnetic flux density. The calculation is given here. So the new magnetic flux density must be 0.499 Tesla, so that the ions can be detected by the same detector placed at the same position. And this is the reason. For C part 1, you find that your B equals Vm over Rq. Your B, Q, and V are constant. Therefore, R is proportional to M, meaning the larger the mass, the larger the radius. So since the mass is 22U, which is larger, so you need a larger radius of curvature. In part B, your B equals to Vm over Rq. This time your V, Q, and R are constant. So R is a constant because of the fixed resistor. The position of the resistor never changes, so R will stay constant. Therefore, your B proportional to M. Because your V and RQ are constant. So I can write down B equals to Km. Then I can set up two equations. 0.454 equals to K times 20 atomic mass unit. Then when the mass of the ions is changed to 22U, then it will be B22 equals to K22, second equation. I take the second equation divided by the first equation. I'll get B22 divided by 0.454 equals to 22 over 20. Then I can get the answer here. Same as this working here.